Hey guys, today we're going to learn about the chain rule. Now, before we get into that, I just want to show you why we use the chain rule. So we're going to work with this problem first using the method that we have learned, and then I'm going to show you how to find the derivative of that function using the chain rule and how much easier it could be. So we have f of x is equal to 2x plus 3, all of that cubed. And first, in order to find this derivative in the past, we learned that we would have to multiply this all out so that we can get it in polynomial form and then find the derivative. So let's go ahead and start with that. So f of x is equal to 2x plus 3 times 2x plus 3 times 2x plus 3. Remember, when you are multiplying multiple terms, you can only multiply 2 at a time, and then you go ahead and get that product and multiply it with the third. So I'm going to first multiply 2 of these. So I'm going to FOIL these two binomials first, which would give us 4x squared plus 6x plus another 6x, which is plus 12x plus 9. And now we're going to distribute that with 2x plus 3. So I'm going to distribute this 4x squared first, which gives us 8x cubed plus 12x squared. Now I'm going to distribute the 12x, which would be plus 24x squared plus 36x. And now finally distributing the 9, we get plus 18x plus 27. And when we combine like terms, this gives us 8x to the third plus 36x squared plus 54x plus 27. So this is f of x. So now I'm ready to find the derivative, which is f prime of x. So the derivative would be 24x squared plus 72x plus 54. This is my derivative. Now imagine if it wasn't 2x plus 3 to the third, but it was 2x plus 3 to the seventh. That would be a lot of multiplication that we would have to do before we can actually find the derivative, which what happens with that when we multiply for an extensive period of time, there are more chances for us to make mistakes. So this is why we use the chain rule. And the chain rule allows us to find the derivative of a composite function in a much simpler way. Now this is a composite function because we have a function within a function. We have 2x plus 3 within the parentheses, and then it's being raised to the third. So here, this is the chain rule of differentiation. If you have a function such that f of x of g of x, meaning that g of x is plugged inside of f of x, then the derivative would be f prime of g of x times the derivative of the inside, which would be g prime. And I put here in blue, think of your composite functions as onions, where you find the derivative of the outer layer and multiply with the derivative of the inner layer. If there are multiple layers, then you work your way towards the center. So I said like an onion because it's kind of like you're pulling away the layers. You first start with the derivative of the outside, and then you multiply with the derivative of the inside. So now let's look at how I would use the chain rule to find the derivative of the function that we just did. So this is the function we just worked with, the 2x plus 3 to the third. And if I were to apply the chain rule, what we have here, this is your outer function. It's the to the third. And the inner function is the 2x plus 3. So first what we have to do is apply the power rule to the outside, right? So we're going to move the 3 to the front, leave the inside alone, don't change it. So it'll be 3 2x plus 3 squared. And then I'm going to multiply with the derivative of the inside. And the derivative of 2x plus 3 is 2. So now if I want to simplify this, this would be 6 times 2x plus 3 squared. Now this would be my derivative. You don't have to keep going. You can leave your answer like that. But just to show you how this equals to what we found earlier, we're going to go ahead and distribute it so that you can compare. So we have f prime of x, which is equal to 6 times 2x plus 3 squared, which means 2x plus 3 times 2x plus 3. So I'm going to go ahead and distribute the 2x plus 3's. And this would give me 6 times 4x squared times 6x times another 6x, which is plus 12x plus 9. And when I distribute the 6, that gives me 24x squared plus 72x plus 54. And if I go back to what we just did, you see that it is the same derivative. And look at the amount of work I had to do before versus after. Okay, so the chain rule makes this a lot more possible and makes it a lot easier to find the derivative of a function like this. So let's try this with a few other examples. For f of x, we have 3x squared plus 2 all raised to the third. So remember, we're working our way from the outside in. So f prime of x, we're going to work from the outside first, so that 3 is going to be moved to the front. So 3 times 3x squared plus 2 squared times the derivative of the inside, which is 6x. And now I can simplify this by multiplying the 3 with the 6x, which is 18x times 3x squared plus 2 squared. And this would be my derivative. You don't have to keep multiplying it out. You can just leave it like that. Now for b, we have f of x is equal to the square root of 2x plus 5. Now, whenever you're finding the derivative of anything that has a radical, please remember to rewrite the radical using rational exponents first. So the square root of 2x plus 5 is equivalent to 2x plus 5 raised to the 1/2. Now I'm ready to find the derivative. And again, this is the chain rule. So I move the fraction to the front. So 1/2 times 2x plus 5 raised to the negative 1/2 times the derivative of 2x plus 5, which is 2. So the 1/2 and the 2 cancels out, and I'm left with my derivative of 2x plus 5 raised to the negative 1/2. Now, typically, if this was a multiple choice question or even an FRQ, you don't really want to leave any negative exponents. And additionally, you should also, if you can, write it with the radical, just so that you can see your function better, because typically we find a derivative and then plug in a number to get the slope. So it's a lot easier to figure out what that slope is if you have the radical written out. So I can rewrite this as 1 over, since the negative exponent means it goes down to the denominator, and since the exponent is 1/2, that's going to be the square root of 2x plus 5. So this is my derivative. Moving along to c, we have f of x is equal to 5 times the cube root of x plus 2 squared. Now to rewrite this, we have the 5, and then the x plus 2, remember that when you have a radical with an exponent, the root is the denominator and the power is the numerator. So this would be x plus 2 raised to the 2 over 3. So when I find my derivative, that 2/3 comes to the front, gets multiplied with the 5. So 5 times 2 over 3 times x plus 2. I'm going to subtract 1 from the numerator, from the exponent, so negative 1 over 3. And then times the derivative of the inside, which is just 1. Put this all together, we have 10 over 3. And since this is a negative exponent, that means that it goes down to the denominator with the 3. And then the exponent is 1/3, so that is the cube root of x plus 2. And that would be my derivative. Now for d, we have f of x is equal to cosine squared of 3x. Now this is important. All trig functions are chain rule functions, and that's because we have the trigonometric function and then the angle. Now in the past we never had to use the chain rule because the angle was always x. So the derivative of x is just 1. That does not affect our overall derivative. But if you have an angle that is something else, such as 3x, then you would have to apply the chain rule. So let me show you what I mean by that. First of all, I'm going to have to rewrite this with the exponent. So cosine squared, please keep in mind, that's cosine of 3x. All of cosine is raised to the second power. And I put the angle in parentheses so you can see the layers. So we work our way from the outside in. And in this particular case, we have 3 layers because I have the exponent, that is the outermost part. Then we have the trig function, and then we have the angle. So here we go. When we find the derivative, we bring the 2 to the front. So 2 cosine of 3x. Now I find the derivative of the inner function, which is cosine. So the derivative of cosine is negative sine of 3x. And then I multiply with the derivative of the angle, that is our final layer, which is 3. Now I can put all of this together, and the only thing that I can really combine is the 2, the negative, and the 3. 2 times negative 1 times 3 is negative 6 cosine 3x sine 3x. And this would be considered my derivative. Let's look at another example. So here we have the function f of theta is equal to sine squared theta when theta is 3 pi equals to 3 pi over 4. And we're trying to find the slope of the tangent line. So remember that we need to find f prime of theta first. Now just as a reminder again, right, f of theta is equal to sine theta. All of sine is being squared. So this is, again, the chain rule. So when I use f prime of theta, when I find it rather, we bring the 2 to the front, so 2 sine theta, and I multiply with the derivative of sine, which is cosine theta. And if theta was something else, like if my angle was something different, then I would have to multiply by the derivative of the angle. But the derivative of theta is just 1, so this is my final derivative. So now I need to plug in f prime of 3 pi over 4, which is going to equal to 2 sine of 3 pi over 4 over times sine, times cosine of 3 pi over 4. Now remember, we need to know our unit circle. Here we have our quadrants 1, 2, 3, 4. You only really need to know quadrant 1. And then just remember to use the mnemonic I showed you guys, ASTC, all students take calculus. This means that only sine is positive in quadrant 2. And I say quadrant 2 because 3 pi over 4 is located in quadrant 2. And remember, you can remember this because in quadrant 2, right, the numerator is always 1 less than the denominator. So only sine is positive. That means that cosine will be negative. So when I'm finding these values, we have 2. Sine of 3 pi over 4 is a positive square root of 2 over 2. The cosine of 3 pi over 4 is negative square root of 2 over 2 because cosine is negative in quadrant 2. And now we work this out. So the 2's here, they can cancel out. And then we have square root of 2 times negative square root of 2, which is negative 2 over 2. And negative 2 divided by 2 is negative 1. So that is my slope. Now let's look at some examples when we have to use a combination of rules. Okay, so we just learned the big 3 rules of differentiation, the product, quotient, and chain rule. But a lot of the times your derivatives are not solely just one of these rules. You may have to use a combination. So for example, for A, we have f of x is equal to 5x times the square root of x plus 3. This is a product. So I'm going to have to use the product rule. And this is 5x times x plus 3 to the 1/2. Now, when I use my product rule, you're going to see now when we work this out, we're going to also have to apply the chain rule for this particular function, for the x plus 3 raised to the 1/2. So here we go. F prime of x is going to equal to 5, the derivative of the first, leave the second alone, x plus 3 to the 1/2, plus 5x, now times the derivative of the second, which is 1/2, times x plus 3 to the negative 1/2. When I simplify this as much as possible, we get 5 square root of x plus 3. This will be plus, now everything in the numerator is just the 5x, and the 2 and the x plus 3 to the negative 1/2 goes down to the denominator. So I can rewrite all of this as 5x over 2 times the square root of x plus 3. This is not a very pretty answer, nor is it a usual answer for multiple choice questions. So we should be able to try to figure out how to rewrite this as one fraction rather than having something plus a fraction. So in order to do that, we need a common denominator. And if you're ever unsure about your common denominator, you can just take the current denominators and multiply them together. So for 5 square root of x plus 3, it's always just over 1 since it is not a fraction. And so our common denominator would be 1 times 2 square root of x plus 3, which is 2 square root of x plus 3. So my common denominator, I'm going to need to multiply this one here by 2 square root of x plus 3. And then I have to do the same thing to the numerator. So times 2 square root of x plus 3. And so I can rewrite this as 5 times 2, which is 10. Square root of x plus 3 times the square root of x plus 3 is just x plus 3. Then plus the 5x. And now that everything has the same denominator, we can put it all over 2 square root of x plus 3. I can distribute this 10, which will give me 10x plus 5x, so 15x, plus 10 times 3, which is 30, all over 2 square root x plus 3. And this would be a much nicer looking derivative than the previous. Now let's go ahead and look at g of x. G of x is equal to sine of 2x plus 1 over x minus 3. Now we can see here that the main rule is going to be the chain rule because this is a trig function. And remember, all trig functions are chain rule functions. And the angle is a quotient. So we're going to have to use the quotient rule in addition to the chain rule. So let's go. G prime of x is going to equal to, remember, our first layer is going to be the derivative of the trig function, which is cosine. And we leave the angle alone. Now I'm going to multiply that by the derivative of the angle. So remember, this is quotient rule. So low, x minus 3, d high, which is 2, less high, 2x plus 1, d low, which is just 1, all over x minus 3 squared. The only thing that I can really work with is this numerator, and we can simplify this a little bit. So I'm going to distribute this 2, and we get cosine of 2x plus 1 over x minus 3, times 2x minus 6 minus 2x minus 7, minus 1, sorry, over x minus 3 squared. These two x's cancel, and then negative 6 minus 1 is negative 7. So our final answer would be cosine of 2x plus 1 over x minus 3 times negative 7 over x minus 3 squared. And that's it. This would be my answer. Please remember that you cannot multiply this 2x plus 1 with the negative 7 over x minus 3 squared because that 2x plus 1 over x minus 3 is an angle, whereas the negative 7 times x minus 3 squared is not. So you cannot combine it. We just leave it like that. Let's look at a more challenging question. We're going to find the derivative of this function. H of x is equal to the square root of 2x plus 5 over x minus 3. Now when I look at this initially, I know I'm going to have to use the quotient rule because this is a quotient. But then additionally, in the numerator, we have a square root, which is already a chain rule function. So I'm just going to go ahead and rewrite h of x as 2x plus 5 raised to the 1/2 over x minus 3. So now let's go ahead and find that derivative. So h prime of x is going to equal to low x minus 3 d high. So I'm going to find the derivative of this, which is chain rule. So that's going to be 1/2 times 2x plus 5 to the negative 1/2 times the derivative of the inside, which is 2, less high, which is 2x plus 5 to the 1/2, d low, which is 1, all over x minus 3 squared. Now I'm ready to start simplifying. Automatically, I see this 1/2 and this 2, they will cancel. And in the numerator, we can see here that x minus 3 times 2x plus 5 to the negative 1/2, this is going to go down underneath x minus 3 because of that negative exponent. So when I rewrite it, this is x minus 3 over the square root of 2x plus 5 minus the square root of 2x plus 5, and everything is over x minus 3 squared. Now from here, this is not very pretty, nor is it very functional, so we need to find a common denominator for the numerator of this complex fraction and simplify. This, as always, over 1. Our common denominator is going to be the square root of 2x plus 5. So I'm going to have to multiply the square root of 2x plus 5 here, as well as in the numerator. So what this ends up giving me is x minus 3 over the square root of 2x plus 5 minus, now when I multiply this, the square roots cancel, so it'll be minus 2x plus 5 over the square root of 2x plus 5, and everything is over x minus 3 squared. Now let's rewrite this again just a little bit nicer. All of this is considered to be over the same denominator, so I can distribute the negative, combine like terms, and put it all over the square root of 2x plus 5. So we have x minus 2x, so negative x. And then negative 3 minus 5 is negative 8, all over the square root of 2x plus 5. And this is all over x minus 3 squared. Now when you think about it, this is a fraction divided by, we can make this also into a fraction. And when you're dividing fractions, remember that you copy, change, flip, meaning that you multiply the numerator with the reciprocal of the denominator. So this is equal to negative x minus 8 over the square root of 2x plus 5 times 1 over x minus 3 squared. And now you can put this all together. So my final answer would be negative x minus 8 over x minus 3 squared times square root of 2x plus 5. Now I usually write my factors in front of the square root just because sometimes it could look confusing. Maybe it looks like it's underneath the square root as well. But regardless, if you wrote it afterwards, it's fine. Both are equivalent answers. Now we're going to look at a graph. So here we have the graph of h of x. Find the equation of the tangent line to the graph of p of x, which is equal to the square root of h of x when x is equal to -4. So again, we need the point and we need the slope. So first I'm going to go ahead and find the point of tangency. So I'm going to look for p of -4, which is equal to the square root of h of -4, which is the square root. H of -4 is right here, which is 4, and the square root of 4 is 2. So that's my point of tangency, -4, 2. Now let's go ahead and find the derivative so we can figure out the slope. So p prime of x. Now remember, p of x is equal to the square root of h of x, which is the same thing as saying h of x raised to the 1/2. So when I find this derivative, that's going to be 1/2 h of x to the -1/2, and then I'm going to have to multiply by the derivative of the inside, which is h of x, so h prime of x. Now let's rewrite this so we can find the derivative easier. The only thing that's going to stay in the numerator is the h prime, and in the denominator we have the 2, and we have the h of x to the -1/2 since of that negative exponent, so that's the square root of h of x. Now I'm ready to plug in the -4. So p prime of -4 is going to equal to h prime of -4 over 2 times the square root of h of -4. As a reminder, and I put it here, to find h prime of x at a particular value from the graph, find the slope of the graph at that point. So here's the -4. This is a line. To find h prime, I need to find the slope of the line, which when I look at it, I have to go down 2, right 4, which is -2 over 4, which again can be simplified to -1/2, over 2 times the square root of h of -4, which we had done earlier, that's 2. So this gives me -1/2 over 4, which we can put over 1, and then we have a fraction divided by a fraction, so we're going to multiply the numerator by the reciprocal, and we get the derivative is equal to -1 over 8. So this is all we need. We have the point of tangency, so the -4, 2, and the slope. So my equation would be y minus 2 is equal to -1 over 8, parentheses, x plus 4. Finally, let's look at a chart. We have here a chart where we have f of x, g of x, f prime, and g prime. Is the graph of h of x, which equals to f of g of x, increasing, decreasing, or at a relative maximum or minimum when x is equal to 3? And give a reason for your answer. To determine if our graph is increasing or decreasing, etc., we need to find the first derivative. Remember that the first derivative tells us the behavior of our graph. So we need to find h prime of x. And as you can see, this is the chain rule. We have g of x inside of f of x. So first, remember, we find the derivative outside, so f prime of g of x. And then we multiply that with the derivative of the inside, so g prime of x. Now I'm ready to plug in 3, which is going to equal to f prime of g of 3 times g prime of 3. When I look at the chart to get these values, I get f prime, now g of 3 is 4, and then times g prime of 3, which is 6. Okay, so especially when you're working with composite functions, you have to look at your chart a couple times simply because it's f prime of whatever g of 3 was. So now that we have g of 3, now I have to find f prime of that value. So I'm looking for f prime of 4, which is 8. So 8 times 6 is 48. Now, so my h prime of 3 is equal to 48. Since my derivative is not 0, it's not a maximum or a minimum, but it is positive, so that means that h of x is increasing at x is equal to 3 because h prime of 3 is greater than 0. Let's look at the next one. If p of x is equal to g of 2x, what is the value of p prime of 1? So first, let's find the derivative, p prime of x. This is another chain rule. Remember, you have 2x inside of g. So the derivative of the outside, which is g prime of 2x, and then we're going to multiply by the derivative of the inside, which is 2. So now I'm ready to plug in 1. So p prime of 1 is going to equal to g prime of 2 times 1, which is 2, times 2. G prime of 2 is negative 1 times 2, which is equal to negative 2. And that's my derivative for p prime of 1. For this last one here, we have if q of x is equal to the square root of f of x plus g of x, what is the value of q prime of 4? What does this say about the graph of q of x when x is equal to 4? So first I'm going to rewrite q of x using my rational exponent. So that's f of x plus g of x raised to the 1/2. So now we're ready to find the derivative. So q prime of x is going to equal to 1/2 f of x plus g of x raised to the negative 1/2 times, now the derivative of the inside, which is f prime of x plus g prime of x. This is my derivative. I can rewrite this now so it's a little bit easier to work with. Since this is a negative exponent, we're going to move that to the denominator along with the 2, and everything else stays in the numerator. So q prime of x is equal to f prime of x plus g prime of x all over 2 times the square root, since it is raised to the 1/2, of f of x plus g of x. And now we're ready to plug in the 4. So q prime of 4 is equal to f prime of 4 plus g prime of 4 all over 2 times the square root of f of 4 plus g of 4. So now I'm going to use my chart here to get these values. F prime of 4 is 8 plus g prime of 4, which is negative 2, so minus 2, over 2 times the square root of f of 4, which is 1, plus g of 4, which is 7. And this gives me 6 over 2 square root of 8, which can be simplified to be 3 over the square root of 8. Or if you wanted to simplify that radical even more, that gives us 3 over 2 square root of 2. So this is my derivative. Now, the question does have a follow-up, which is, what does this say about the graph of q of x when x is equal to 4? Now, because my derivative is positive, that means that my function is increasing. So we would say that q of x is increasing at x is equal to 4 because q prime of 4 is greater than 0. And that's a chain rule.